In this set of problems, we are asked to rewrite without rational exponents and simplify. So here is number 1. Number 1 says y to the 1/7 power, which has, as you can see, a fraction for an exponent. That's why it's called a rational exponent, because of that fraction there. Whenever we have a fraction for an exponent, the denominator of the fraction tells us the index of my radical expression, and if the denominator tells us the index, the numerator is the exponent of the base. So if it said y to the 2/3 power, then the index on my radical would be this number here. It would go there. It would be a third root, and it would be the third root of y to that power there. So the third root of y squared. In this case, we have y to the 1/7 power. So what we're looking for is the 7th root of y. And we don't need to put the 1 here as an exponent for y, because we know y is y to the 1st power. All right, number 2. This is x to the 1/6 power. So with 6 being our index, then we have the 6th root of x to the 1st power, or just x. 8 to the 1/3 power. Now this one's a little more interesting, because when we take the cube root, sorry, that was a fail. Let's draw the radical first. When we take the cube root of 8, 8 is the cube root of 2 times 2 times 2. And since I have 3 2's, then I have a cube root of 8, which is 2. So 8 to the 1/3 power is 2. That's the simplify part. We're able to simplify number 3. 4. 16, it says 16 to the 1/2 power, or the square root of 16. And remember, when I don't put the index here, when I don't indicate an index, then I assume it's the square root. And I know that 16 is 4 times 4. 4 times 4 means that the principal square root of 16 is 4. Get some more room. Number 5 says a to the 3rd power, b to the 3rd power, raised to the 1/5 power. So the 1/5, remember, tells us that we're taking the 5th root of whatever's in here to the 1st power, and whatever is in here in these parentheses is a cubed, b cubed. In the next set of questions, we're asked to undo our radical expression and turn it into an expression with a rational exponent. So here we have the square root of 17, and as you know, 17 is implied to be to the 1st power because there's 1/17 there. We're multiplying 17 by itself one time only. So because 17 is to the 1st power, then we can say that 17 will be to the 1 over something. Now what is that thing? That thing is the index of the root here. Now remember, a blank index on a radical implies 2. So it'll be 17 to the 1/2 power. So the square root of 17 is the same as saying, is equivalent to saying 17 to the 1/2 power. Let's look at number 12. Number 12 says take the square root of x to the 3rd power. Now here we have something, we have a exponent underneath the radical, and the radical has an index of 2, an implied index of 2. So whatever x is going to be, it'll be to the 3/2 power. 3 coming from the exponent on the x, and 2 coming from the index of the radical. Let's look at 13. 13 says, it says this, the cube root of 18. And so 18, again, remember, is to the first power, so it's 18 to the 1/3 power. Let's try 14. It's the cube root, sorry, that's not a very good cube index here, the third root of 23. And again, 23 is to the first power, so it's 23 to the 1/3 power. So being able to translate between expressions with rational exponents to radicals and expressions with radicals to a rational exponent is a good skill to have. It will be something that we will be tested on in our common mastery assessments. Now we're going to use that skill immediately by using rational exponents to simplify expressions. For instance, in number 69, we're given the radical expression, the sixth root of 4 times x to the second power, and we're asked to simplify that. Well, it may not be obvious how to take the sixth root using the radical expression, so if we go ahead and change that to 4x squared to the 1/6 power, we can now use our rules of exponents in order to simplify. And it goes a little something like this. 4 is the same as 2 squared x squared. And we're going to raise that to the 1/6 power. Now remember, when we have an exponent and we're raising it to an exponent, then it's the same thing as multiplying those exponents. So 2 times 1/6 is the same as saying 2 to the 2/6 power. X squared, 2 times 1/6 again is x to the 2/6 power. Now 2/6 in both of these instances is very we can reduce that fraction. So it'll be 2 to the 2/6 is the same as 1/3, or 2 to the 1/3 power, and x to the 1/3 power. And notice how we have the same exponent here, right? So when we have the same exponent, it's like undoing this situation, right? We multiply that exponent in. Well, here we can just take that exponent out and say that it's 2x raised to the 1/3 power, because it has the same exponent. So it's almost like factoring out that exponent. And we can rewrite that as a radical by writing the third root of 2x. And there's our answer there. So the sixth root of 4x squared is equivalent to the third root of 2x. Let's try number 70. Number 70 says the third root of 8y to the 6th power. 8y to the 6th power. Again, first step is to make it a fractional exponent, or a rational exponent. So 8y to the 6th power raised to the 1/3 power. And it's always best to understand these numbers, are integers, as as exponents. So we know 8 is 2 times 2 times 2, so that's 2 to the 3rd power times y to the 6th power raised to the 1/3 power. Raising exponents to exponents, we multiply. So that'll be 2 to the 3/3, or first power, and y times y to the 6/3 power. Well, let's actually do let's actually, so we don't get confused. Y to the 3/3, 2 to the 3/3, y to the 6. Now we can simplify that. 3 over 3 is 1, so it's 2 to the first power. 6 divided by 3 is 2. So the cubed root of 8y to the 6th power is equivalent to 2y squared. So we don't miss any steps. What do you think of that? Pretty nice, huh? Couple more. This video is a little bit longer than the last, just because we had some more work to do. 71. It says the square root of x to the 4th y to the 6th. First step, let's turn it into rational exponent. Second step, distribute the exponent. Third step, rationalize the exponent. 4 divided by 2 is squared. Y, 6 divided by 3 is, 6 divided by 2 is cubed. And then that's our answer there. 72 will be the 4th root of 16x to the 4th and y squared, which is 2 to the 4th power. 16 is 2 to the 4th power, x to the 4th, y squared, all raised to the 1/4 power. So that's 2 to the 4 over 4 times x to the 4 over 4 times y to the 2 over 4. That's the same as 2 to the 1st, x to the 1st, and y to the 1/2. And to simplify that all the way, I have 1 to 1x and the square root of y. 1 to 1x times the square root of y. And then that's my answer there. Now number 80 just asks us to do the same thing, only backwards. So number 80 says the cube root of, well, I guess it's not backwards, x squared, which is just supposed to be a little bit harder, y to the 5th, and I'm going to raise all of that to the 12th. Okay, so inside the parenthesis I have the expression x squared y to the 5th, and I'm raising that to the 1/3 power. And I'm taking all of that and now raising it to the 12th power. So now I need to distribute inside the parentheses first. Always do the innermost parentheses first. So that'll be x 2 to the 1/3 is 2/3, y 5 to the 1/3 is 5/3, and I'm going to raise all of that to the 12th power. And I'm just going to multiply these out, but you'll see how that works. It shouldn't be terribly difficult. Oops, not y first, x first. X 12 to the 12 times 2 is 24/3. Y to the 60 over 3, and let's finally bring this home. X 24 divided by 3 is to the 8th power. Y 60 divided by 3 is to the 20th power, and we are simplified.